Now for this next step in our example, we want to contrast using a different approach, using a genetic search algorithm, and we're going to use one that's implemented in a Dynamo package that's called Optimo. Now, you'll need to have Optimo installed on your machine for this to work, and we'll kind of show you what that looks like in the Dynamo environment in just a second. But if you're trying this and things aren't working, first thing that'll probably you want to check is just to make sure that you have Optimo installed. And in this example, we're again going to set up our test environment. We're going to create a first generation of XY pairs. So that won't be an exhaustive list of all the XY pairs. It's just going to be automatically generated. We're going to say how many people or how many members we want in that generation. That's the population. Then we're going to evaluate those test cases. Those are the members of that population in the first generation. Then based on the results, we're going to create a next generation of XY pairs based on the kind of traits that seem to be the most favorable, that gave the best evaluations. So let's just kind of walk through how we can do that. So it all starts with just setting up the testing environment. Again, we're going to select the face and we're going to set up the variables. Again, a range of X values to test, a range of Y values to test. Okay, so let's just go ahead and take a look at this. In the Optimo world, it looks like this. Now, if you have Optimo installed, which you can check by going to your packages and manage the packages, and we're going to be looking for Optimo 0.1.2. It's kind of an older package now that's been replaced with another technology we'll use in a few moments called Project Refinery, but it's still available to search for. So if you have that installed, it'll show up down here. Okay, and there's just a few functions that are nodes that are associated with that. Okay, so we're basically ready to use it. Okay, what we're going to do is, again, select the face, as we talked about, or we have in the past. Okay, we are going to basically set up the first generation, and our first generation looks like this. We need to set up the upper and lower limits for the variables we want to test. And the lower limits are the lower limits of both the X and the Y. The upper limits are the upper limits of both the X and the Y. So it's the same values that I've put up here. I'm just going to get the lower limits. And I'm going to use the same lower limit for both the X and the Y. And the same upper limit for both the X and the Y. We'll also go through and set up the number of members that we want to have in our population. We also need to tell Optimo, though, just a little bit about really the number of objectives or evaluation functions we're going to be using, as well as the number of iterations we want to run, how many different generations we want to use. And this is all going to be plugged into this function to create some initial solutions. So we're going to set up the testing environment. We're then going to create our first generation of XY pairs using this Optimo function called NSGA to initial solutions list, where we feed it the population size, the upper and lower limits, and the number of objectives. Okay, so let's take a look at that. So with that filled in so far, we can go through and run. Now the initial generation is really not all that interesting. Let's just take a look at it. It's basically randomly generated some points, which you're seeing in front of the list is all the X values. So this is a random list of values between 0 and 90. There's 50 members in our population. If we continue to scroll on down, you'll see there are some Y values. And finally, there's some Z values, but the Z values are all 0 right now because they haven't yet been evaluated. Okay, so that's our initial population. Okay, what we're going to do is after we generate our initial population is we're going to evaluate each of these different members of the population using a function that again is going to return the Z value for each of the pairs. Okay. In order to make that work, you could have multiple evaluations. So Optimo uses this notion of a list of different fitness or evaluation functions that it wants to apply. And the function apply basically feeds the members of the population to each of those different functions. So this little bit of hierarchy, which I'll point to here, the point on surface fitness evaluation, that's very similar to the one we used up here. It's actually kind of a copy of the function with the inputs looking a little bit differently. We're going to function apply and feed that population to each of these different fitness functions. Now, this part will look just the same regardless of what you try to do with Optimo. This surface fitness function, that's the evaluation function, that'll look a little bit different. So that's the part that gets customized. Okay, so you'll have as many different evaluators as you're trying to report different evaluation values and use them for the optimization. After we've evaluated, kind of using that, we are going to basically set up a loop to create the next generation of XY pairs. So there's a loop while, which just sets up the loop to iterate until the condition is met, where the condition is really just to have you completed the number of iterations that you wanted. We have this NSGA to assign fitness function results that matches the results to the members of the population. So it'll take all the Z values that were computed and match them up with the X and Y's. And then we also have this function which basically generates the next generation of the population based on the results. So out of here, we're going to Optimo, and this little loop is pretty much all set up for you. There's a while loop, and the while loop basically associates the fitness function results and then generates the new results, or the next generation of results. Super. And when you do this, this is going to just keep on iterating through a number of times until you kind of achieve the number of generations that you said that you wanted to run. Okay. The final step in all this is, again, we'll sort of do some visualization. We can kind of separate the results out, and basically the results that come from Optimo are sort of two different indices in a bigger data structure. The first index is the iteration number. The second index, or the first index, index 1, is the list of the different values that are returned, the X, Y, and Z values. We're going to transpose that around just so we could get the X, Y, and Z values together as a group, and then feed that into a watch node just so we can look at the data structure. Then again, we can also look at that visually, just kind of check out the points, the reference points, and just kind of, pardon me, the spheres if we want to visualize it in Dynamo instead. So let's just kind of hook that together. So over here, the result of this function is going to be a list, and it's basically going to be a generation number, and then all the different X, Y, and Z values. What we're going to do is just kind of break that apart a little bit. I'm going to get the results over here, and results 0 is going to be just the generation number, feeding that into a watch node. Results 1 will actually be the data itself, and I'm going to transpose it. So again, I can get the X, Y's, and Z's from being in separate lists into all being together into a list that has the X, Y, and Z values all together. Okay, and we'll watch that. Finally, we could also go through and, again, just do this little point by coordinates exercise to kind of put the spheres in there, just so we can watch it all hanging together. So what I'm going to do is, so that we don't confuse the different things, I'm going to turn off the visualization over here, just so you're not seeing those points. So you can actually see really what the results of this convergence is. So let's just go and run this a couple times and see. We'll be able to see it both in the Dynamo window and in the Revit window. But basically, if you do the first generation only, let's try that. You see it scatters points all over the surface. If you run a second generation, you get a little more convergence. If you run a third generation, it's starting to realize where the most attractive points are. It's getting a little finer. The fourth generation, and again, you could just jump right ahead to as many generations as you want to. You don't need to do this stepwise like I'm doing. Well, we're getting pretty close right now. You can sort of see I have sort of two clusters that appear to be looking pretty good. You'll see I have sort of a, what would I call it? A local optimum over here, and there's the true optimum somewhere over in there. So it might actually take a fifth or a sixth generation to really identify the true optimum. Okay, it looks like for this one, it actually took 5 to get them all clustered pretty darn close. They're not 100% in the same spot right there, but we have a pretty good sense of where that optimum is. Okay, so that's the way Optimo works, and it's really just an implementation of a genetic algorithm, which is again casting out all these different points, evaluating them, then using the strongest trait points to generate the next generation of the different points. So it tries to converge and hopefully do it in a very efficient way. Okay, so let's go ahead and pause there. And next up, we're going to think about just comparing these two different ways of approaching the problem.